Hi there, fourth graders. I hope things are going well for you today. Today we're going to talk about equivalent fractions and simplest form, or a simpler form. These are two great lessons. They're super foundational to fractions, and truthfully, you'll be using both of these skills like the entire rest of your mathematical career. Like you'll use it in algebra and algebra 2. You'll use it if you ever get to like statistics type stuff or calculus. Yeah, you'll be using this for quite a while. So it's a really important skill for us to know. But you cover it again in fifth grade. So my job is just to let's dip our toes in it. Let's get very familiar with it. And you've got plenty of years to learn it, but let's try and get it learned and down pat right now. I've got a joke for you though. Here's my fraction joke. I heard once that there is a fine line between a numerator and a denominator, and only a fraction of people will understand that joke. Right? Fine line between numerator and denominator. Fraction, right? You with me? Okay. Today's math. It's very doable. It's so doable. But students kind of try and mix it up in their heads sometime. So there's two things we're going to be talking about. Finding an equivalent fraction. And then we're also going to be talking about how to find a specific type of equivalent fraction that we call simplest form. In both of these, we're trying to find a fraction that is worth the same amount as the original fraction. We're trying to find a fraction that uses a different number of pieces to describe the same overall amount. So first off, let's just talk about equivalent fractions, because that one's actually quite a bit easier. Now, if you remember the identity property of multiplication, you remember that anything times 1 equals that number. So 8 times 1 equals 8. You'll remember that 27 times 1 equals 8. You'll remember that 5,362 times 1 equals, that's funny. 8 times 1 equals 8. 27 times 1 equals 8. I can do math, folks. I can do math. I almost put 8 down there. Anyway, equals 5,362. That's the identity property of multiplication. So what the identity property of multiplication says is that if you want to multiply a number and have the answer be the same as the original number, you just multiply it by 1, which is what we're doing today. So let's take, for example, this fraction right here. 2 parts shaded out of 3. That's 2/3. And I want to find a fraction that is equivalent to that 2/3. Well, what the identity property of multiplication says, that if I want to find a fraction that's equivalent to 2/3, all I have to do is multiply it by 1. Now, fortunately for you and me, we know of a lot of different ways to write 1 as a fraction. We can write 1, I'm just going to list some examples down here. We can write 1 as 2/2, because 2/2 is 2 parts shaded out of 2. We can write 1 as 3/3, because it's 3 parts shaded out of 3. The whole is shaded in. We could do 4/4. We could do 5/5. We could do 99/99. All of those are fractions that are equal to 1. So if we want to find a fraction that's the same as 2/3, we just multiply it by 1. So I'm going to pick 2/2 just for kicks and giggles. Because remember, here's my 2/2 down here. 2 parts shaded out of 2, right? That equals 1 whole. So 2/3 times 2/2. When I'm multiplying fractions, I can just go straight across the top, remember. 2 times 2 equals 4. And on the bottom, 3 times 2 equals 6. So my fraction that's equivalent to 2/3 is 1, 2, 3, 4, 5, 6. And I shade in 3, 4. And if you look at my pictures, I always recommend calculate this first because when you're drawing fractions, it's really hard to be precise and it's really, really easy to make a sloppy mistake when you're trying to draw with just draw the fractions comparing it. That was okay for 3rd grade, but by 4th grade, we've got to be able to calculate it. But if you look at my picture model I used to check, this 2/3 is worth, yeah, those are pretty darn close as the 4/6. So I'll show one more example because that one's usually a little bit easier for students to grasp, and then we'll jump into simplest form. So let's say I do 4/7, and I want to find a fraction that's the same thing as 4/7. So over here, just for us to check when we're done, I'll just 1, 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4. I want to find a fraction that is worth the same amount as 4/7. So to do that, I'm just going to multiply by a fraction that's equal to 1. And you can use any fraction that's equal to 1. Any of them. Any of them. So for this one, I'm just going to pick 3/3. Oof. Yeah, I'll pick 3/3. And that equals 4 times 3, multiplying across the top is 12. And 7 times 3 is 21. Let's see if I can turn this into 21ths. So 12 21ths or 12 21sts is equal to 4/7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, I kind of ran out of space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pretty close. My picture, I shouldn't have done 21st because that's a really, really small pieces, but they are equivalent. 12, so what we're saying here is that 4/7 is equivalent to 12 21st. They are worth the exact same amount. They're just numbers that are expressed using a different amount of pieces. Now let's get to a very specific type of equivalent fraction, and that's called simplest form. And you might already be remembering the jingle in your head. Simplest form factors. But what simplest form says is that sometimes we actually want to have a fraction that's worth the same amount, but that uses less pieces. So let's take, for example, 5/10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nah, I didn't have enough space on it. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now, if I want to find a fraction, well, I'll show you what I mean by simplest form first. So if I shade in 5/10, 1, 2, 3, 4, 5, you know, there's a lot of pieces here, and not every piece actually has to be used. Sometimes we can take out groups of pieces at a time, and that helps us to get to what we call simplest form. So in this case, 5/10 is actually equal to 1/2. Those are two fractions that are equivalent. The difference is that the 1/2 is in simplest form, or it's using the fewest amount of pieces while keeping the amount of the number that's expressed the same. So let me show you how we find simplest form. So let's start with this 5/10 example again. The key is that we have to be able, if we're going to simplify it, you can't just deal with either the numerator or the denominator. If you do that, then you're changing the amount of the number because you're going to change a numerator but leave the denominator the same. So the trick is with fractions is if you're going, you have to change both of the numbers to keep the ratio or the amount that they're worth the same. So to do that, this is how, there's several ways out there to do it, but you know me, I'm always a fan of a systematic way, of a way that, you know, if you do it this way, the exact same way every time, it will get you to the correct answer. There are other ways to find fractions. Some kids just try and divide by 2 and try and divide by 3 and then divide by 2 again until they get it, which can work, but this is my systematic way that I've found that if students can get this down, they'll get it right every single time. So the thing that we do is we list out the factors of both numbers, or the numbers that we can multiply together to equal the number. So the factors of 5 are 1 and 5. And the factors of 10 are 1 and 2 and 5 and 10. What we want to do is find the biggest number that is common between these two factors. It's called the greatest common factor. So I can circle that number. The greatest common factor between 5 and 10 is 5. So what that means is that I can divide 5 divided by 5, and I can divide 10 divided by 5. 5 divided by 5 equals 1, and 10 divided by 5 equals 2. So 5/10 is actually equal to 1/2. Those are equivalent fractions. And notice this one only uses 2 pieces, where this one uses 10. So it's simpler because it uses less pieces. And then it's simplest because it's using the absolute least amount. Let's try 2 more examples with simplest form. Let's try 9/12. So if you remember, your steps for finding simplest form is you need to list out the factors of both the top and the bottom number, and then we're going to divide by the biggest number that's found in both numbers, that's found in the factors of both numbers. So for 9, that would be 1 is a factor of 9. I can do 1 times 9. 3 is a factor of 9. I can do 3 times 3. And 9 is a factor of 9 because I can do 9 times 1. Those are all the numbers that I can multiply together to equal 9. 12. 1 is a factor of 12. I can do 1 times 12. 2 is a factor of 12. I can do 2 times 6. 3 is a factor of 12. I can do 3 times 4. 4 is a factor of 12. I can do 4 times 3. 6 is a factor of 12. I can do 6 times 2. And 12 is a factor of 12. I can do 12 times 1. Now, if you're a little hazy, you can go back to my video from Thursday and Friday from last week, where I walk you through a systematic way to find all of the factors. But I'm assuming you can already find factors, so I'm going to go a little bit quicker through that part. So in this case, I want to find the number that's the biggest number that's on this list and this list. Can you find that number? It is 3. So what that means, I'm going to divide 9 by 3 on the top so I can get fewer pieces in my denominator. And I'm going to divide 12 by 3 on the bottom so I can get fewer pieces in my denominator. So 9 divided by 3 equals 3. And 12 divided by 3 equals 4. 9/12 and 3/4. Those are equivalent fractions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. So there's my 3/4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice, my picture doesn't quite line up just because, it's hard to draw 12ths exactly accurate, and this picture might be a smidgen bigger. But, you can see that, yeah, I mean, if my picture was exact, then the 2 would line up. But I did the math. I divided by the largest common factor between the 2, and so I know that 3/4 is equal to 9/12, and 3/4 would be 9/12 in its simplest form. Let's try one more. Let me think of a good one. 12/28. So 12 pieces out of 28 total. Now again, to find simplest form, I'm going to list out the factors of 12. 1, 2, 3, 4, 6, and 12. And my factor of 28, 1 is a factor of 28. 2 is, right? 2 times 14. I can't do 3. 3 can't go into it, but 4 can. 4 and 7. Can't do 5. Can't do 6. I can do 7. And the next one would be 14 and then 28. So what's the biggest common factor that you see on both these lists? I see 4. There's 2 here, so we can divide by 2 to get a simpler form, but when we divide by 4, we can get a simplest form. So I'm going to do 12 divided by 4 from my numerator, 28 divided by 4 on my denominator, 12 divided by 4 is 3. 28 divided by 4 is 7. So 12 28ths is equal to 3/7, and 3/7 is in simplest form. So thank you so much for watching my math video today. Please remember that there is a fine line between numerators and denominators. Was that my joke today or was that yesterday's joke? I can't remember. But anyway, thanks so much for watching. Bye-bye. Erase. Too little.